And here we go. This is the Hoodie graph to generate this road. And you can change it in real time. Pretty cool, huh? Hello everyone and welcome to the 4th episode of my Devlog series. I'm developing Hoodie, a visual scripting interface to generate procedural geometry, just like Blender geometry nodes, but integrated directly into Godot 4. Today, I want to announce that version 0.2-alpha is out now. It's free and open source. Go get it on the GitHub page. Since this is completely free, if you want to support me and Hoodie development, you can either do that by buying me a coffee or through the Gumroad Hoodie membership. Check the page to learn about the additional perks. Every amount goes a long way. Links in the description below. But now, the new features packed in this release. I'm Green Crow Dev, let's get started. Alright, I don't even know where to start, but let's first create a new scene, okay? A new 3D scene, and let's create a mesh instance 3D so that we can create our new Hoodie mesh. Here we go, this is our new graph. Let's start by creating a simple cube, but first thing first, you can now use right-click on your mouse to create new Hoodie nodes. Let's create an output node. Here we go. And next to this one, let's create a cube node. So we'll find it in mesh primitives cube. Let's connect this one into the output. And here we go. We have a white cube, but what you don't see right now is that this also supports custom materials. Here is an empty material, but we can create a new one and change its color so that we can see it better. Here we go. And now we can change, for example, the size of the cube. Oh no, sorry, not an input value, a vector one. Since we can change its size in its 3 dimensions. Here we go. This is a 1 by 1 by 1 cube, but we can change its X, Y, and Z dimension. Alright, and everything works as expected. Another simple thing that we can do is move this cube with a transform node in geometry, operations, transform geometry. Alright. Here we go, like this. It will not move at all, since we need to give it a vector, input vector 3D, and here we go. We can work our cube on the x-axis, y, and z. It works as expected. But now let me show you something a little bit more interesting. Let's create a new path node. Let's change the bake interval so that will not be too dense. Alright. And now let's import this curve in our graph. Add node, input curve 3D. Here in the inspector, let's add the curve, but first we need to copy it from here. Alright. And let's paste it right here. Now we have the curve. What we can do is, using this node, curve to points that will basically decompose the curve into its values, for example, its points. And what we can do is connect points to the translation of the transform mesh to displace our cube, that's not a cube anymore, but onto the curve. And this also changes in real time. If we go to the path 3D and modify the curve, we can see that we'll displace our cubes, accordingly. There we go. Pretty cool. But why is this happening? Okay, if we just use this vector and connect it to the transfer mesh, we can see here on the left that we have one value that's a vector 3D value with index 0 with these x, y, z values that goes into the transfer mesh. But this curve to points is different because it has not just one value, but it has 17 from index 0 to 16. So what happens is the graph will move the cube for each one of these points. And this is why it will generate these other cubes on the curve. On the left, we have this panel that it's very useful to debug how the output values of our nodes work. For example, you can also check the tangents values for the curve, changing the tab. We can do the same thing for the output node. We can inspect the vertex values and each other one that has some value, for example the UV. We can just try to use some texture to see how that works. Let's do that on a curve 3D and use it like a road. So first thing first, let's create a new path that we will use as the curve that will generate the road. Yeah, here we go. Okay, let's import this other curve. Alright. And now let's use curve to mesh node, but we also need a profile that in this case will just be a mesh line. Let's create a new output node. And there we go. This is our road. Add a texture to see if that works. Here in the expector, surface number 1, name 12 corresponds to this output node. Let's create a new shader. And let's add this texture as the color, but it doesn't look good. It's not correct because basically UVs are flipped. I'm not sure if I should correct this, probably yes, but we can do that here in the graph anyway. If you notice, it takes a little bit of time to update the custom inspector. So we can basically lock it with this lock icon and it will not update. How to do that? We can use utilities, mesh, compose mesh, and decompose mesh. This just explodes our mesh data so that we can do stuff in between that. We want for sure vertex, indices, normals, tangents, and UV. Here we go. If we connect this, the output will be the same. Here we go. But what we want to do is change the text UV indices. Let's do that by using another utility, utilities, vector, separate xy and combine xy. Let's swap X and Y like this and connect the output again. Here we go. Still, it's pretty compressed. We need to stretch it a little bit. Let's do that right now using a multiply node, an input value. But which one should we multiply? I'm not sure. Let's try the X one. Don't forget to connect it. Yes. Here we go. Now the UVs look good. Don't forget that you can always change the path in real time. Here we go. Okay, if you wanted to change the weight of the road, you can absolutely do that. We need to change the values of the mesh line. That's the profile that gets extruded along the curve. Let's do that by using a couple of the vector 3D nodes. Also, now we have copy pasting and duplication stuff for Hoodie nodes. For example, if I want to just duplicate, I can select this vector 3D and use Ctrl D to duplicate it, but I can also copy with Ctrl C and paste it with Ctrl V. It's the same thing in this case. So let's use -1 as the start location of the line and 1 for the offset. That's already the default value. So what we can do is change its width. Basically with -1 and 1, this road is 2 meters wide. For example, -5 and 0.5. Now basically the road will extrude with its curve on the center. We can use another profile. Instead of mesh line, we can use a mesh circle. But this is not just a circle, we can also use this to generate other polygons. It just depends on the number of vertices, but let's use default values. Let's connect mesh circle to profile. And here we go. This looks bad, but just because the default values is 3, so this is just a triangle. And we probably also need to flip this. Yeah, here we go. Once we flip the surface, we get a good looking result. But for example, if you wanted to see the inside of this triangular tube, you can use not flipped curved mesh. If you want like this, yeah. We can also increase the number of vertices, so it's not a triangle. We can do a square pipe, but you can have as many vertices as you want. And you can also change the radius. Here we go. I don't know what this is, but yeah. As the last thing for today, let's just add a collider for our shape, but let's change the scene a little bit. Let's try this, but we also need a camera, yeah. Yes, here we go. And now we just need to add a collider to our mesh. Let's click on our Hoodie mesh, click on mesh and create tri-mesh static body. Here we go. Well, the count seems pretty high. We can redo that, but by reducing here the resolution of the curve, for example, from 0.2 to 0.6. Better, probably. Let's do it again. Here we go. Seems a little bit better. And let's see what happens. But I'm not sure. Here we go. Yay! Let's go! Alright guys, if you enjoyed the video, leave a like and subscribe to the channel. See you in the next one. Bye!